Hi everyone, welcome to another video today. Um, for this video, I'm gonna present to you the MicroVM Architecture-Agnostic that's powered my QSLCL, which is why my QSLCL doesn't have a static architecture like ARM64, RISC-V, MIPS, PowerPC, and so on. So let's start. So here we are. This is the assembly of my QSLCL.bin, or it is named is qslcl.asm for assembly. So as you can see here, this is the registers. So you might see it closely, and also this is the memory regions, which is the standard layout from build.by. That is also uses some QSLCL BST, or it is part of the bootstrap. So you can see here, and this is the status flags, which stored the special status register. So you may read this closely, and this is the section 2. This uses the UOP, which is the dictionaries of some of the micro VM instructions. So this is the core operations. There you go. And also the memory operations, which is also uses some load 8, store 8, load 16, store 16, load 32, and so on. And this is where we are also executing some commands with payloads, like for example read, write, erase, poke, and so on. And also this is the system operations, which also send the interpreter when you are running some commands, so the device will acknowledge it. So there you go. And also this is the IPC operations, which also uses some of the instructions to interact with hardware, like some of the CPU. So the CPU will interpret it, and also to execute some of the commands like read partitions, write partition, and so on accurately. So you can see here. And also this is the IO operations, which interpret some of the operations in some memory regions, like for example when you're interpreting to BootROM, when you're interpreting to some of the random access memory, or some flash, or some bootloaders, and so on. And this is the crypto operations, which is part of the QSLCL ENC, and it uses the encryption. If some of the vendors implement a USB frame encryption in their devices, so to accept some of the commands, so it uses this one. Yeah, there you go. And this is debug operations. If you are trying to execute some registers, and it is part of the runtime table fault, or the if it is send the success failed messages, for example success 0, failed 0, 1, and so on. And also this is the power operations, which uses some of the instruction that loader will do if it is success or fails, and it uses some of the instructions to execute some dangerous commands like voltage, and so on. And this one is the fault recovery, which is part of the RTF. So it will send some of the messages if it is successful, failed. And this is the USB core operations, which also part of the QSLCL USB. So there you go. So this is the USB data operation, which is part of QSLCL USB also. If we are trying to send some endpoints, or endpoints in and out some of the instructions like 01 in 081 endpoints in out, for example. So this is the data transfer protocol, which is part of the QSLCL data, which also the data transfer. So there you go. And this is the bootstrap operations, which is part of the bootstrap QSLCL BST, which also uses the init, verified, jump, setup, secure, recover. And this is the USB 4 v2.0 operations, which is part of the USB 4 v2 MC, which uses the USB 4 version 2.0, which is the 80 Gbps. So you can see here. And this is the macros, with the common instruction patterns on how it corresponds to the code generated by build.py. So this is part of the commands like QSLCL CMD. This is how some of the commands will be interpreted in order to be executed correctly. So here we go. Look at it. You see, it's just a simple instructions actually. This is the example programs, which also part of the hello command. And this is the get info command. This is the read command, write command, row mode command, test command, post command, and this is how some of the headers are structured. It is the command definitions, which is also the 28 commands actually. You can see here there's a read, write, erase, pick, poke, patch, dump, hello, ping, get info, get sector, and so on and so forth. This is the system call numbers, which also uses the SYSCALL in custom na tied to the static architecture like ARM64, ARM32, or some of the x86, 64. It is the fault codes actually is just a basic. You can see here. This is the USB 4 constants. This is the command families, and there you go. That's it. So here you go, guys. I already present to you the MicroVM instructions. If you're interested in this video, like and subscribe and click the notifications to stay updated to my video. Thank you guys, and see you there soon.